Hello, and welcome to 5-Minute Math. Today we are looking at the fifth grade concept of generating additive and multiplicative patterns. This is 5.4c, Readiness Practice, the intermediate version. If you are interested in exploring the proficient or advanced versions of 5.4c or the Readiness Practice resource line with any other standard, you can find those by using the link in the video description. So we have a blank table here, and we have a rule. Emma's saving money for a new bike. She's going to save $5 a week. So we have this rule y equals 5x. And so this y, we're going to take our 5x, and that's going to equal our y if we want to look at it this way. And the 5 next to the x, that means we're going to multiply. When you have a number right next to a letter, which is an unknown, and there's no operation in between, you can assume it's multiplication. So what we can do here is we can take our 5 and we're going to replace the x with the weeks because the weeks represents our x. So $5 on the first week. I'm going to do 5 parentheses 1. That's going to also represent multiplication. There's many ways for us to represent multiplication. So we can say this is 5 parentheses 2, 5 times 2, 5 for the third week, 5 for the fourth week, and then 5 times the fifth week. So really what we're doing is we are just going to take each of those expressions. We're going to simplify them. 5 times 1 makes 5. 5 times 2 makes 10, and so on. And so it looks like we're just counting by fives if we're looking up and down, but really we're going side to side. We need to know that rule, y equals 5x, because we now need to figure out what is the total amount that Emma will save after 10 weeks. Well, we could extend our table down to 6, 7, 8, 9, and 10 weeks. We don't need to. So let's just extend our table one row. And let's say this is 10 weeks. And what is our rule? Well, it's 5x, and our x is 10. So we're going to take 5. We're going to multiply that by 10, and that's going to be 50. So we can say she will save. Let's put our answer here in dollars, $50 after 10 weeks. All right, so we use that 5 times our x to get the y. Now that last one was a table. For our second problem, we are looking at a graph here. So Coach Maria, we have some practices here, and our rule is y equals 2x. Now, we have a blank graph. Our x-axis always goes side to side. Our y-axis always goes up and down. So we need to find how many hours of practice team will complete after 1, 3, and 5 practices. Okay, so let's see if we can label this, right? We can go ahead and just put our numbers since we have this blank graph. Let's skip count by ones because that's probably going to be all we need. But sometimes we need to skip count by twos if we get this multiplicative relationships. So we're going to go ahead and put these up like this because we want to label this, and we need to put names on what is the x-axis, what is the y-axis. Well, it says here, x represents the number of practices. Okay, so I'm going to put number of practices. What does the y represent? Total hours of practice. And so if you look at the problem itself, it's going to define, it's always going to need to define for you what is the x and what is the y. So now we look at our second paragraph here. How many hours of practice will the team complete after 1, 3, and 5 practices? So if I've got, let's circle this, 1, 3, and 5 practices, how many total hours will we have? So I need to plot these. Well, let's make ourselves a little table. So the x's they want me to look at are 1, 3, and 5. So I'm needing to generate some y values so we can put these on the coordinate grid. Now we go back to our rule. 2x equals y. I just took my y equals 2x and I flipped it around so it's the same direction as my table. So I'm going to take my x1 and I'm going to multiply it by 2, and that's going to get me my y. I'm going to take my 3, multiply it by 2. I'm going to take my 5 and also multiply it by 2. And I can just put it into an equation like this, and look what I get. I get 2 I get 6, and I get 10. So what I get are 3 coordinate pairs. So if I look at my x value, right, this is going to be 1, comma 2. This is going to be 3, comma 6. And then this is going to be 5, comma 10. And so that 10 is going to work, but just barely. We're getting close to needing to use a different scale. If we went up to 6, we'd get up to 12, and that's as high as we could go with this current scale. But we can get it to work. So one practice is going to get me 2 hours. So let's put that right there. 3 practices gets me 6 hours. So I'm going to go 3, comma 6. And then 5 hours gets me 10 practices way up here. You notice it's steep, but it is a straight line. Okay? So that's how we can show our answers in both a table and a graph. All right, and so we need this third problem is also going to show us that we've got a graph. We need to create a table as well. We've got a baker, starts with 5 pounds of flour and then buys 3 more pounds each day. And then we have a relationship. Look at this expression here. So before I label my graph, I'm going to go ahead and create a table because I don't know what my interval needs to be. So here's my rule, and you notice we're going to start with 5 pounds, and then what we're going to do is we're going to add uh, that 5 pounds, and then we're going to multiply by 3 by the number of days. So each total number of pounds y is, the times p. So let's put that down here. So I'm going to put my table. I'm going to say instead of x and y, I've got p and y, and that's fine. Okay. And then what I want to do is I want to put an expression. So I'm going to give myself a little bit of room. And so let's put an expression here. I'm going to put p and do this. Just because I got to do 2 things. I've got to multiply by 3 and I've got to add 5. So I'm going to put my y equals, that's going to be 3p plus 5. So this is going to help me calculate. Okay? So my 3p plus 5, this is my rule. Remember, my 3p plus 5 equals my y. I just flipped it around. And so what we need to do is we need to create a table. We get to choose the data after each of the first 5 days. So let's do each day p is going to be 1, 2, 3, 4, 5. Okay, so let's do 1, 2, 3, 4, 5. Now we take the day, we multiply it by 3. So we're going to take 3 by 1, but then we have to add that 5 that he started with. So 3 times 1 is 3. Add the 5. That's going to give me 8. Now I'm going to take my 3 and I'm going to multiply that by 2 days. That's 6. Add the 5, and that's going to get me 11. So I'm going to take my 3, add the 3 days, multiply by 3, that's 9, add the 5, that's 14. So you notice my y is still going up by 3, but I'm looking side to side here. So that's going to be, let's get that to be 4 times 3 is 12, add the 5. You notice we're up to 17, and then 5 times 3 is going to equal 15, add the 5 is 20. So I wanted to check my scale. This is the same size graph we had last time, so that counting by ones is not going to work. And so let's skip count by 2s, and that's going to give us a little bit more flexibility, especially when we need to get up to 20. So 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And what is our x-axis? Well, our x-axis, we're actually going to call that p. So just to be a little bit clear, we're going to replace it with p, but it's going to kind of serve the same purpose as our x-axis, and that is going to be number of pounds each day. So I'm going to say number of pounds bought each day. And so that is what our x-axis, in this case our p-axis, is going to represent bought each day. And then what is our y-axis? We need to label that, and that is going to be the y-axis, the total number of pounds. We're also going to skip count by twos, and it's really for the y-axis that we need to skip count by twos because the first 5 days is gonna get us a value all the way up to 20. And so if we went up to 12, it's not going to do enough, but look, I've got at least 20. And so this is my y-axis, and we can say total number of pounds. All right, and so now we have our table. I just need to go ahead and convert these into some XY coordinates. I'm looking at P and Y, so I'm just going to put them over here. I'm going to do 1, 8. Let's move that because that logo is going to be in the way. Let's do it over here. 1, 8. Let's do 2, 11. Let's do 3, 14. 4, 17. And then 5, 20. And if we can plot these, we will have graphs. So 1, 8. Now we're going to have to think about our p-values. If it's odd, it's going to be between the numbers. I've got 2 and 11, so that's going to be right here. I've got 3 and 14, so my p-values are just going up by 1. But you notice my y-values are going up by 3. I've got 4 and 17, so it still makes a straight line. It just doesn't go through the origin of 0, 0. And then 4, 17, what's the last one? 5 and 20. So 5 and then my 20, and so I've got room up here. So that's how we could graph this. That's how we can put this on a table to show this relationship y equals 3p plus 5. If you are interested in exploring 5.4c Readiness Practice resource for the proficient or the advanced version, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description.